Hi, I'm Karen Jex. I'm a Senior Solutions Architect at Crunchy Data. Prior to that, I was a DBA and then a database consultant. And today I'm going to talk about multi-tenancy in Postgres. So welcome to Divide and Conquer. So this is just a brief overview of what we're going to go through today. There'll be an introduction to what multi-tenancy is and why you need to think about it. We'll set the scene, imagining that you're the DBA for an organization that needs to implement a multi-tenant database architecture. We'll have a look at the various different multi-tenant architectures that you could put in place. We'll look at how you could choose which one of those is appropriate for your use case. And then we'll have a look at what we've learned. So first of all, what is multi-tenancy? What do I mean by multi-tenancy? Here I mean hosting one or more database applications or users, the tenants, on a single VM or server or Postgres cluster. And why do you need to think about multi-tenancy? Well, because most organizations don't have just a single Postgres database or a single Postgres database application. When I started out as a junior DBA, I was a team of 4 DBAs, and we managed 2 database applications between us, each of which was on a standalone database, and there was absolutely no complexity. But things have changed. Things aren't like that anymore. You probably manage multiple databases, multiple database applications. Each of those applications probably has multiple different internal or external users. So you're going to have to think about multi-tenancy for at least some of those, because it's often expensive and too complicated to manage an individual Postgres database or cluster for each of those. So because cake's one of my favorite things, and because my sister runs a bakery and some of her creations have elephants on them, I'm going to use the example of a bakery as an organization that needs to put in place a multi-tenant organization. So imagine that you've been brought in as the DBA for Hooray for Cake, a popular local bakery that started out as a one-person organization managing all of their data in spreadsheets, but it's growing rapidly and it's soon going to have franchises all across Europe. You've been told that each of those franchises needs to manage its own data, but that some data is going to be accessed centrally by head office for reporting purposes. And you need to decide how best to organize your databases for the current and future needs of the business. You've created yourself a data model. You know you're going to need to add franchise to that at some point. And you know that you're going to use Postgres as your database, obviously. But what next? How do you know how many Postgres clusters you need? How many databases are you going to need? Do you need multiple schemas? For your initial architecture, you'll probably put something like this in place. So you'll have a single host. Here we've got HFCVM, a single Postgres cluster, HFC cluster, a single database, HFCDB in this case, with a single cluster that contains the tables. But how would you change that once you've got multiple franchises? So you might, for example, have London, Paris, and Berlin franchises to manage. Or what about if you had hundreds or even thousands of franchises around the world? I mean, that's my idea of world domination there. You'll need to think about different multi-tenant options. You can organize your Postgres databases in various different ways to meet the needs of different applications and users. But which is the right one? Well, as always, it depends. the right architecture for you is going to be the one that balances various different requirements. So performance. Is performance good enough for all of your tenants? Does one of your tenants adversely impact some of the others? How isolated do the tenants need to be? Do they have some degree of interdependence, or do they have to be managed completely independently? There are going to be cost implications. You're going to have to think about how much different licensing costs, your hardware, your management, your personnel. High availability. Do they all have the same high availability requirements? Do they all have the same maintenance windows? Manageability in terms of whether you want to manage everything centrally, whether you're going to perform backup and restore for all of your tenants at once, how big a team you have to manage things. And sometimes customer confidence. Sometimes a customer will say they need a particular architecture. And sometimes that's for good reason. And other times you'll need to work with the customer to explain to them that actually another architecture is more appropriate and will give them what they need. So I'm going to use cakes as an analogy. Just as you could have one or more trays that contain one or more plates, and on each of those plates we could put one or more cakes. Those cakes could be made up of multiple tiers, and you can cut those cakes into multiple slices. We can have one or more VMs or servers for our Postgres clusters. Each of those servers could have one or more clusters on it. We could have more than one database in each of those clusters. We could have a collection of schemas inside each of our databases, and then inside each of those schemas we have a number of tables. Excuse me. So we can separate out the different franchises, the different tenants at any of those levels. At one end of the scale, we could have 3 trays, each of which has an individual plate, and on that individual plate, we've got a single cake. Now that's got some advantages. That means we can send those cakes off to different places if we want to. Each person getting a cake can choose their own size of cake, the flavor that they prefer, the decoration that they prefer, and we can display them on the plate and tray of that customer's choice. But on the other hand, you're going to end up needing a lot of trays and a lot of plates, and it could be very time consuming to bake and decorate all of those different cakes. So we can liken this approach to having one host per tenant. So we have each of our tenants on its own VM with its own cluster, schema, and tables. So for each tenant, for each franchise, we would have a whole setup as we saw in that first original architecture diagram. Now, this isn't really a multi-tenant architecture. You are having a completely separate architecture for each of your tenants. This is the architecture that gives you the most flexibility and the most separation between your different tenants. So parameters can be set at the operating system level, at the Postgres level for each of your tenants, so they can be configured to their own requirements. You can perform upgrades for just one tenant at a time. You can perform backup and restore for just one tenant at a time. And performance of one tenant can't be adversely impacted by another. You have scalability. You can add a whole server for any new tenant that comes online. And if you need to, you can geographically distribute your tenants. You can create those servers wherever you want to. On the other hand, things like global reporting are more complicated. So report across all data, you might need to put something like foreign data wrappers in place so that you can access all of the data on those different servers. Shared reference data becomes quite difficult to manage. You will probably need to put something like logical replication in place if you want to share reference data amongst the tenants. And you have high overheads because you need to set up an entire new VM with its Postgres cluster, the database, the schema, etc., every time you add a franchise. you've then got to set up your monitoring, maintenance, and all of your different tasks for each franchise. This can be a useful architecture if you've got tenants that need to be managed completely separately, if you need to have high isolation between your tenants, and if you don't have any shared data. At the other end of the scale, I've used a multi-layered cake as an example. So you just serve a single cake on a single tray with multiple layers. So the advantage here is that you've just got to bake a single cake. You only have to have a single tray and a single plate. On the other hand, you can only take that cake to one place, and everybody has to have a piece of exactly the same cake displayed and served in exactly the same way. And I'm likening this to an architecture with partition tables. So we'd have a single VM with a single Postgres cluster, one database, and just a single schema with one set of tables, which are then partitioned out so that you've got a partition for each of your tenants. You'd need to put some schema changes in place if you wanted this kind of architecture. So you'd need to create yourself a franchise table, add the franchise ID to all of the tables that contain franchise-specific information, partition those tables by franchise ID. So you wouldn't need to partition any shared reference tables, but you would need to partition things like your customer data, for example, your order data. And make sure that your application is changed as necessary so that it just selects the items, the rows that are relevant to a particular franchise. Now you might ask, how can I make sure that the data is secure, that franchises can only see data that's relevant to their own franchise, that they can't see other people's data? So for that, you've got an interesting solution in Postgres. We have what we call row level security, or RLS. So I've given the link to the documentation there. You would enable row level security on any of the tables that you need to. And once you've done that, you create security policies. So you could say that franchisees are only allowed to see their own data, whereas the head office staff are allowed to see all data for certain things so that they can create reports across all of the franchises. So the advantages of this approach, we can easily share our reference data. So we just have that in non-partition tables where the information is available to all of our franchises. We can easily perform global reporting because everything's in a single database and it's all in single tables. So to do global reporting, we just need to do a select from the whole table, not just one of the partitions. And we've got lower overheads than the one VM per tenant because we've just got a single server to manage with a single Postgres cluster. We just need to add a partition to each of those partition tables if we create a new franchise. So things like monitoring, maintenance are reduced because we just have to do everything once for everybody. On the other hand, we have reduced flexibility. Any parameters have to be changed for everybody at once. We can't customize things just for one tenant. We've got reduced separation. So upgrades have to be performed for everybody at once, whether that's operating system, Postgres, or schema upgrades. Backup and restore impacts all of our tenants. So we can't just restore data for one tenant. We have to do it for the whole of our Postgres cluster, which is for everybody. And if we've got heavy use by one of our tenants, then that could impact performance of the others. So this could be a useful architecture if you have everything managed centrally, if global reporting is important to you, and probably just if you have a small number of tenants, because if you have hundreds or potentially thousands of tenants, you're going to start getting a very, very large number of partitions quite quickly. So in between those two extremes of one server per tenant and one server for everybody with partition tables, you've got various different options. And each of those is going to give a different combination of flexibility, maintenance, and isolation. So we'll look at some of those different options. And I won't give all of the advantages and disadvantages of each, but just mention a few key points about each of those. So we've got one tray with each cake on its own plate, which I'm using to represent a single server or VM, but then with each tenant having its own Postgres cluster. So here I've got a single HFC VM, I've got a London cluster, a Paris cluster, and a Berlin cluster. Here you've just got to note that each of those clusters needs its own name and will be listening on a different port. You could again have one tray, but this time have all of the cakes on a single plate. And I'm using that to represent one database per tenant. So we've again got a single server, but this time we're just creating one Postgres cluster, HFC cluster. And this time we're creating a database, so for London, a database for Paris, and a database for Berlin, each of which will contain their own schema. This, to me, actually gives us the worst of both worlds in some ways. We've got everything in a single database, in a single database cluster. So that means that things like backup and restore have to be done for all tenants at once. Our parameters, for the most part, are just for everybody. We can't configure things for individual tenants. And on the other hand, even though everything's in the same cluster, because they're in a different database, we can't easily do global reporting across all of our databases. We still need to put in some kind of structure such as foreign data wrappers to access the data in all of the databases for global reporting. Likewise, for shared reference data, because everything's in different databases, we would still have to do something like logical replication to make sure that that data was available in all of the databases. We could create a multi-tiered cake, or one schema per tenant. So here we've got just a single server, a single Postgres cluster, a single database, and we've created a schema per tenant. Excuse me, I'm just going to move back to the correct slide. So we could have one cake that we cut into slices. And by that, I mean one set of tables per franchise. So this is almost the same as having one schema per franchise. I mean, a schema is just a namespace after all. But in this case, we'd have to rename all the tables so that the table names don't clash. And we'd have to make sure that the application was changed so that it accessed the correct tables for each franchise. We could go back to the idea of having a layered cake, but we could separate the layers out and send them to different places. I'm probably taking the cake analogy slightly too far now. But I'm using this to indicate the idea of sharding. So sharding is an extension to the idea of partitioning, but the partitions, instead of all being in the same cluster, are sent off to different clusters. So it almost takes us full circle to the idea of having one VM per tenant. But in this case, we've also got a control VM. So we have a VM that contains our main coordinator tables, and then the partitions in a VM per tenant. Postgres doesn't provide native sharding yet. You can set up your own form of sharding. I've called that the bake-it-yourself sharding version of sharding. But you'd have to partition the tables yourself. You would have to set up foreign data wrappers, for example, so that you could then say where the different partitions of your tables reside. There are lots of steps involved, and it's complicated, and it's almost definitely not something that you would want to implement for yourself in production. Fortunately, you don't have to. You could use an extension such as Citus to do all the heavy lifting for you if you decided that sharding was the right architecture for you. So sharding can be useful if you need geographical distribution of your data. So if your franchises were separated all around the world and you wanted the data to live near to your franchise. If you want a central management, so for example, you're managing the application centrally. And if you want to be able to scale because you can add resources for each of your franchises. You might not even want full-size cakes. I've been talking about VMs, but actually you might prefer to look at a containerized architecture. There are a number of different Postgres operators for Kubernetes that you could look at if you want to implement databases in a containerized environment. And you can do that as its own version of multi-tenancy, or you could use it with some of the other architectures that we've already looked at. So we've looked at various different options that you can use, but how do you choose which one's the right one for you? You need to think about your different requirements. You're going to have to think about what you need and which architecture is going to give you the best balance of those things. So you could look at, for example, the responsibilities. Who's responsible for managing the infrastructure, the application and the schema and the data? Do you have shared data? Do you have shared reference data? Do you need to be able to do global reporting across all of your tenants? There'll be cost implications to the various different architectures. If you're using proprietary software, you could well have licensing implications that you need to look at. How will the choice of architecture affect the costs of hardware or your cloud provider bill? How will the costs of management and maintenance be affected? Do you need geographical distribution? That could be for scaling reasons, for performance, or it could be for privacy or compliance reasons. How many tenants are you going to have? How is performance going to be impacted by the number of tenants? Will your architecture give you the performance that you need? Will you be able to scale as the number of tenants increases? How will your maintenance increase with the number of tenants? What level of isolation do you need between the tenants? Do you want to be able to configure everything centrally? Do you want more flexibility? Do you need to be able to perform upgrades for your individual tenants, or actually do you prefer to perform upgrades for everybody at once? Is it okay for backup and restore to impact all of your tenants? How about performance? Do you need to make sure that performance of one tenant can't impact others? So I've done a comparison over the next couple of slides to help you to look at your requirements, look at the different options and see how they could fit together so that you can choose which one's right for you. And obviously I've used a custom cake-based scale. So just in case that's not obvious to everybody what I mean, I've used a single tiered cake to indicate a yes or a no. So if there's no cake, that's a no. If there's a cake, that's a yes. And then I've got a number of cupcakes to represent a scale from low 1 cupcake through to very high 4 cupcakes. So here you can see if shared reference data and cross-tenant reporting are important to you, you'd probably go for an architecture where you separate out your tenants by schema, or you have one partition per tenant. I've put sharding in brackets here because you can share reference data and can do tenant reporting, but with some degree of complexity. If geographical distribution is important to you, then you're going to probably be looking at having one VM per tenant or potentially sharding. If you need a very high level of isolation for your tenants, then you're probably going to look at one VM per cluster. If you want to keep everything centrally managed, then you'll probably go with schema or partitioning. If you want a lot of flexibility, if you want to be able to configure things per tenant, if you want to be able to perform management and maintenance just for one tenant at a time, then you're probably going to go for one VM per tenant or a sharding architecture. On the other hand, if you want to manage everything centrally, then you're probably going to go for partitioning or having one schema per tenant. And as with most things, the main thing to consider is to keep it simple. You want to choose the architecture that's as simple as possible whilst giving you, whilst responding to your requirements. As we all know, additional complexity almost always introduces more problems than it solves. So as a conclusion, we've seen that there are many multi-tenant options in Postgres, and there's no one right answer. The right answer for you is going to very much depend on your particular requirements and your specific use case. To go quickly back to one of the previous slides, the right architecture balances your various different requirements, so performance, isolation, cost, high availability, manageability, and as I said before, sometimes customer confidence, the architecture that the customer really wants to implement. In the case of Hooray for Cake, so in your role as DBA for Hooray for Cake, you would go through the thought process, think about all those things. You're managing a small number of tenants. You're looking at the moment at 3 franchises. Everything's managed centrally, although the tenants do manage some of their own data. You have shared reference data. You need to be able to do global reporting, but you don't have any privacy or performance concerns that mean you need to geographically distribute that data. So for all those reasons, you decide that you're going to bake a layered cake. You're going to implement a single database with partition tables and row-level security to make sure that each tenant only accesses its own data. And you also decide that you really, really want some cake. Thank you very much.